morning. I got to say, I'm really excited to be here. I got to tell you how I got here. 10 years ago, I went to a conference overseas, and I met one of the co-founders of Nullcon, Asim Jakar, and he said, you got to come to India, and you got to come to Nullcon. And I was like, okay, let me remember that. And then, like a year ago, I ran into Antrish at BlueHat in Redmond, and he was like, you got to come to Nullcon. And something about him, you just can't tell him no. So then I came and spoke at Nullcon, and I got to say, what I found was an audience that was just so passionate, so curious, so enthusiastic about security. They just wanted to learn more. And so I left, and I was just convicted. We had to bring our version of community, BlueHat, to India. We have a lot of great teams here, a lot of great team members, but I really just wanted to be able to bring together and connect with the community here. So I was like, always talking to Tom and Stephanie, and I was like, tell me what we're doing to bring BlueHat to India. So I just want to say, couldn't be more proud to be here with all of you at the first inaugural BlueHat conference in India. So thank you. One of my favorite proverbs is, if you want to go fast, go alone, but if you want to go far, go together. And things like BlueHat, Nullcon, all the B-Sides events that happen all over India, those are all great ways that come together. And the talk I'm going to give today is about how we can all come together. It's called Defending with the Graph of Graphs. And I'll explain in this talk a paradigm that I think will help bring many of the different skill sets that we need together to improve defense. Let me start off with why I'm talking about graphs and graphs of graphs. So I'll start with this picture that I got from Wikipedia. This is like a 3D rendering of a vase. And you might look at it and go, have I seen that before? Where have I seen it before? Where is it from? What culture is that from? But another person might ask, who are the two faces in the picture? Raise your hand if you see the faces in the picture. Okay, if you don't, maybe you see them better now. And this is often one of the things that happens when you bring people together. They have different perspectives. And so they see the same thing from two very different perspectives. And I often find this is true about attack and defense. Red teams view something, and attackers view things very differently often than defenders do. Very differently than IT teams or engineers that build the thing that's getting attacked. And so this difference in perspective, I was wondering, like, how can we find some common way to view what we're trying to do in the world of defense from the same paradigm? So that's what I want to talk about today. I'll start by giving some examples. At Microsoft, we have a taxonomy that we use when we talk about threat actors. And so I'm going to give 3 examples from this world of threat actors here. Our taxonomy, if we have threat actors originating from China, they'll have a suffix Typhoon. If they're originating from Russia, we'll give them Blizzard as a suffix. If we're not exactly sure where they're originating from, we'll give them a storm prefix, and we'll give them a number. So I'll start with a storm group. This is Storm 1101, as we designated. So this is a group that is in the world of cybercrime, and they make a very popular phishing kit. But it's not just standard everyday phishing. We've had some success getting adoption of multi-factor auth. Like, I remember giving a presentation during the pandemic. It's like, there's good news and bad news about MFA. The good news is this era of remote work has driven up the adoption of multi-factor authentication. Like, it has doubled the rates of MFA. I was like, the bad news is it doubled it from 7 to 14%. And I think now we're at like 35%, 40% MFA adoption. But with that success of MFA adoption, attackers are like, now we need to be able to defeat multi-factor authentication. So this is an adversary-in-the-middle phishing kit that they make and then sell. And it's designed to circumvent multi-factor authentication. And I'll just explain a little bit how it works. So in a normal phishing site, user clicks the link and they type their password on the bad guy site, and it's basically game over. But with multi-factor auth, you often have a code or something you have to type in. So in this case, user is lured to the fake site. They type in their password, thinking it's real. And that adversary in the middle site just proxies that to the legitimate site on their behalf. And actually, everything on that page they're looking at, they're actually loading from the real site, so it looks fully faithful to what they're doing. Then they're going to get prompted to enter their code that they get, and maybe they get that code on their phone or an SMS. And so the user types in that code into the browser, and that adversary in the middle page just sends it on to the server. And the result after this authentication with both of these factors is you get a session cookie back to your browser, which the attacker gleefully takes. So now they can act as the user with an token at that point. So that's how adversary in the middle works. Well, they built a toolkit for this, and they started to sell it. First, they're like, look, $100 introductory price. We got customer support. We got stuff on GitHub. We know how to support software. And then their toolkit became popular, very popular. What did this cybercrime group do? They raised their prices. $100? No, $300. And we have a special E5 VIP version of this that is $1,000. So this is the toolkit they make. And if you're a defender, how do you stop this? Well, you might do things like you can deploy software that is protecting all the emails that your users are getting and find these phishing sites and prevent them from ever getting to a link that they could click. That's one thing. Another thing is you can use phish-resistant multi-factor auth, and you won't have this flow happen at all. It just defeats the entire thing. So let me talk about another threat actor, Midnight Blizzard. So Midnight Blizzard is also the actor we've called Nobelium, the actor behind the SolarWinds attack. And as a group, one of the main intelligence agencies out of Russia, they target government organizations, defense contractors. That's really their normal remit. But you can see here the second biggest wedge in the pie chart of who they target are information technology companies. Because if you compromise IT companies, you can get access to all the other wedges of the pie. So they are an actor that really thinks deeply in graphs. They understand exploiting trust. They understand exploiting transitive access, the notion of traversal, and this whole idea of hack one to hack many. So we saw that in SolarWinds. We've also seen them attack SaaS providers, cloud solution providers, identity providers like Okta, because they know hacking one of these organizations gives them access to many downstream victims. We had an incident with Midnight Blizzard that we went public with in January, where we had our corporate network had access to it from a legacy tenant that was stood up many years ago. And inside that legacy tenant was an application. Well, Midnight Blizzard came along, password sprayed that legacy tenant because it wasn't as defended as the corporate network was. And inside that legacy tenant was an OAuth application that had a very powerful permission into the corporate tenant. And so this is application abuse, or OAuth application abuse, combined with password spray. And as a defender, you have a few different ways to mitigate this. You could, one, really cut down on who has these elevated permissions and roles and sort of prune back through privilege reduction. You could look at any app that's multi-tenant, where you go, actually, that app doesn't live inside our corporate tenant. We don't know what the security of it is, and we're just going to disallow those multi-tenant apps. And then a third thing you can do, obviously, you can have multi-factor enabled to break password spray. I'll give you one here. Volt Typhoon. So Volt Typhoon is a group that operates out of China, and they specialize in attacking critical infrastructure, particularly critical infrastructure in the United States, Australia, Guam, things in the Pacific, border of the Pacific region. And part of their method of access when they penetrate organizations is organizations have these appliances on the edge, these network appliances, like VPN appliances. And Volt Typhoon really specializes in having exploits, sometimes like exploits that are just a few days old from a patch going out for these appliances. They run these exploits. Now they're on the VPN appliance. And for them, this is a really great strategy because, one, all those appliances are sitting on the internet by design. So they're on the attack surface. And if you think about a VPN appliance, users authenticate to it. They provide their credentials to it. So it's like being in a credential piggy bank that they can access. And eventually, an admin's going to log on. And back before the pandemic, when most people went into the office, very few people were VPNing. But in this era of remote work and work from home, now maybe over 50% of the employees at an organization are VPNing. So there's a huge concentration of credentials going through this. So as a defender, you make sure you patch these things very quickly, or you could also use a type of authentication that just is not going to spread the credentials to the VPN appliance. So those are 3 examples. The world, though, of a defender often is filled with things like you see on the slide here. You got to know about all the TTPs of attackers, things that are all in the matrix. You got to keep up with the latest attacks. You read the blogs, you read the tweets, and then you write detection rules like Sigma rules, Yara rules, things for your SIEM, etc. Very different world than the world of attack that we just went through with AITM toolkits and other things. So this difference between attack and defense, how can we bring them closer together? So the concept I want to talk to you about today is, I believe there's one unifying concept between attack and defense, that if we embrace it across all the roles in InfoSec, we can really start operating from the same paradigm, and that is the attack graph. Because each example I showed you, you can think of as a graph. Users, like attackers compromising users, exploiting their roles and permissions, those are like nodes and edges in a graph. And so the threat actor wants to get access to nodes. They want to create edges in the graph if they have 0 days. Defenders, we want to cut off those nodes, minimize the edges in the graph. And so if you model this world that we're in as attack graphs, it's something that both attackers and defenders suddenly have the same paradigm. And when they look at that vase, and they see the same thing. So I want to give you some examples here. Like earlier I talked about AITM phishing. What is the attacker doing? They're compromising the user. So you can think of that as, if you represent users in the graph, they've compromised that user node. And then what does a defender do once that user's compromised? They reset their credentials. That's like breaking the edge that the attacker has to that node. And if you want to harden these defensive actions that IT professionals do, like deploying phish resist and MFA, you're preventing those attackers from getting edges to the nodes in your graph. And each of the examples I walk through, you could model through nodes and edges and traversals with a set of rules as a graph. So now with that concept of the attack graph in mind, let me talk about how one might go off building a graph. And the good news is you don't really have to start from scratch here. I've been thinking about graphs for a long time. Back in 2005, I wrote a paper with a colleague of mine. I was working in Windows at the time. Tom was working in Office. And in Windows, I wasn't really thinking about the network yet. I was thinking about local elevation of privilege in Windows. How can you go from a standard user account to local system? And I started to study Windows further, and I'm like, well, if you ever have the right permissions on registry keys and in the file system directories, if you can, let's say, write to a registry key and specify a malicious DLL, and then a local system process will read that registry key, load that DLL, you just have an elevation of privilege from standard user to local system. So I started to work on what are all the different kinds of ways that you can elevate privilege. And so I came up with what you see here on the right is these are the 22 different kinds of rules. If you can write to a registry key that system reads, that's one thing. Processes and threads in Windows have ACLs and permissions on them. And if those give away certain permissions to lower privilege entities, that's a pathway, et cetera, et cetera. So one of the cool things in Microsoft at the time was Bill was the CEO, and every year Bill would take a week off of work. Well, maybe not off of work, but he would take a week away from work, and he would bring a stack of papers, and that was called his Think Week. And any employee could write a paper and submit it for Think Week, and maybe Bill would read your paper. So my colleague Matt and I wrote this paper about using graphs to find elevation of privilege, and then we sent it in, and then we waited, and sure enough, Bill, he chose our paper, and he supplied us comments and sent those back to us, and that was just a really cool thing at the time. And then I'll tell you how you can get 30 minutes with Bill Gates. So after he read the paper, his technical assistant came to my colleague Matt and I, and he said, Bill, to his office, see the demo. And he said, you guys got 20 minutes. And we're like, man, Bill's going to love this. We know he's going to love this topic. 40 minutes. And he's like, fine. So that's how you get 30 minutes with Bill Gates. So we came in, we did the demo. And then 10 years ago, I was working more in the network area. And then I wrote this paper about often defenders think in lists and attackers naturally think in graphs, thinking, how do you pivot around the environment? And how do we bring more of this idea of pivoting, traversal, lateral movement to the world of defense? So if I go back to this example here, let me kind of walk through how would you build a graph to help model this and understand this? So the first thing you go, well, what's in this picture? The first thing we have is assets. You have your users, you have applications, you have service principals in intra. These are different assets that you have in your inventory. So inventory is a really important part of building the graph. The next thing is you have to have attack paths. What creates edges in the graph? These elevated roles and permissions that these service principals are granted, those lead somewhere. Those give you access to things. So those are edges that are in the graph. Where do they go? Well, you put them in the graph, and then you keep building the graph. And then the last thing that's important to load into the graph is activity, because none of these graphs are static. There's always things happening. Pass rates are happening. They got a user account, other kinds of activity. You need all three categories to go build a graph. So let me walk through assets, activity, and attack paths. So with assets, there's a lot of tools already available, both open source and commercial, to help build a graph from your assets. This is an open source tool you can find on GitHub by Dow Jones. It's called Hammer, and it inventories and knows a lot about infrastructure and AWS. It knows about all the different componentry in AWS, all the different permissions and roles in that world. It can help build a graph there. This is another tool called Cloud Mapper, and Cloud Mapper understands network traffic in the cloud, and it can help understand, are these things possible to get from A to B in the cloud? The Lyft company built a tool called Cartography, and it's like building an attack graph, and it knows how to take data from AWS, Azure, and a whole bunch of other services, and it has this attack path knowledge to connect them. So those are open source commercial tools. There's a company called Illumio. They make a tool that can build attack graphs with network data. Alario does the same thing with access control graphs, and then at Microsoft, we have the Microsoft Graph. So there's already a lot of things to start with to help build up your asset inventory and connectivity. Now let me talk about getting data out of activity. So if you've ever watched a detective show, there's always that detective that's like trying to find the serial killer. If you kind of ask, well, who was the first detective? This gentleman, Dr. Locard, was the world's first detective. And he was a French criminologist, and one of his maxims was, every contact leaves a trace. And that was meant from a forensic perspective, like, there's going to be a bloody footprint, there's going to be broken glass, you're going to find scratch marks. Those things, those forensic things, are there, and they're like mute witnesses to the crime. And if you can find them and get them, it will help understand what happened. Dr. Locard, he was the world's first detective. And that idea of every contact leaves a trace, I feel like the world of defenders, that is very much the way that we work. Every contact by the adversary leaves a trace in a log. That's why defenders collect logs. Logs are how we see and sense in the environment. And to understand an attack, you have to understand how to interpret all the logs from all over your environment to find those attacks that are in disguise. And one of those logs, for example, may indicate an admin is logged onto a particular machine at this time. And if an attacker compromises that machine, they can get that admin's credentials at that time. So that's activity. And then the last category is attack paths. So there are a number of open source tools that also embody these attack paths. So earlier when I talked about that tool we demoed to Bill Gates, I had those 22 rules. Those were, you could run this script on your computer and it would help identify 22 different kinds of attack paths and put those into a graph. BlueHat is one of the most common open source tools that's available that builds attack graphs for Active Directory and Azure Active Directory. And then commercial products like Wiz and Microsoft Defender for Cloud all have this notion of attack paths in them. So let me walk you through an attack path. This is from BlueHat. So this is run on an Active Directory network. And it has this part of running BlueHat is running all these asset inventory components, which you see here. This is gathering users and roles and machines and all the different sessions, all the things from your environment, and then modeling it in the graph. And so what are the nodes and edges in this graph? Well, the nodes are things like machines and user accounts, and the edges are things like this user is a member of this group. This group is nested into this other group. And on this computer is a live session by an administrator. And so this allows you to understand the attack paths that get from one place in the graph where the attacker may land through spear phishing, password spraying, you name it, and then go, where can I go? And because it's in a graph, you can write graph queries and say, how do I get to domain admin? And this will tell you how to get there. So BlueHat has a tool called SharpHound, and it will inventory an on-prem network. They also have one for Azure, and this is the kind of assets that it will inventory from Azure. At Microsoft, we have our own attack graph, and we have over 100 different types of entities that it inventories, and you can get a sense of the scale. The Microsoft networks are large because they power not only our corporate network, but also the cloud. You can see our attack graph has 400 million nodes, 1 billion edges in it, many different properties in it. So that's the scale of the attack graph at Microsoft. And so this is where I get to what I started with, where you need to defend, you really need to build a graph of graphs, because it's not just information about attacks. You need to understand the inventory of your digital estate, all those assets, that's a graph. The entitlements, the roles, the permissions that connect user accounts to resources, that's your entitlement graph. The network graph, are things connected? How do you get from here to there to there? That's the network graph. Threats, vulnerabilities, patch status, all these different things. So that's why all of this is really a graph of graphs problem. So one thing that I started with that I want to walk through now is I think this graph of graphs idea will also help facilitate collaboration, because I mentioned the attack graph to me is like one of the best paradigms that every different part of the InfoSec team can work on. And so there is this InfoSec color wheel that was developed by April and her collaborator. And the idea is, on the world of defense, we have the blue team. The blue team is there in the SOC, investigating, hunting, watching over things in the network. You also have the red team, doing adversary emulation, finding weaknesses and attacks in the network. And then when they work together, you have this notion of purple teaming. There's also this concept of, well, we also want to continue to just harden the environment and improve things and de-risk the environment. That's done by a team called the green team. And the way you can think of them is they're looking at all the different attack surface that's in the environment. They're rolling out multi-factor authentication. They're minimizing the kinds of credentials and whatnot. So every part of the organization, in a way, has a role in information security. And each of these roles has something to do with the attack graph. Obviously, with the red team, it's pretty clear. They can come up with new ways to create edges, like those 22 rules. They can come up with, actually, my security research showed I know this way to abuse technology that's new, and that's new kind of edges in the graph. As they do their attacks, they're going to use this attack graph to exploit the network that they're testing. A blue team is going to use this attack graph and go, how did the attacker got in? We just got an alert on this host over here. How could they have gotten in? Let's look at the graph to figure that out. What's the blast radius that could go from here? That's they can use the graph to figure that out. And then green teams can identify, how do we minimize, where is there a huge concentration and fan out in the graph? And how do we minimize and shape and harden that? And so that's why
I really view this as a graph of graphs problem, where at the core, you have the underlying security graph that comes from assets, activity, and attack paths. Then you have this attack graph layer on top of it. And maybe during an incident, you have a subset of that, which is just a projection. That is just the stuff happening during that incident. So you don't have to deal with the entire hairball of the graph at one time. And then for threat intel, where we know different adversaries are doing what, and you're getting IOCs, you can use that to decorate your graph and enrich it and whatnot and create connections across it. So one of the ways that we use this graph at Microsoft is we use it in these green team ways, and we can visualize remediation. So we have ways to score the severity of nodes and edges in the graph. And when we find that something happens in the environment, because we're rebuilding the graph every day. And when, for example, somebody, an engineer, configures something in prod and adds, say, an access path for what should have only been in their pre-production infrastructure, but accidentally adds that authorization to production, suddenly there's a huge explosion of access that's possible to production in their service. And we saw an instance of that, and you can see automatically, because that was reflected in the attack graph, we got this huge increase in this risk score. And because we could compute that, the team could get notified about it, and then they could go remediate, and you could see the risk score go down. Similarly, during an incident, when you find like, hey, these credentials have been exposed, or we need to go remediate this whole set of assets, you can just measure, you can see as remediation actions happen, you can see that reflected in your attack graph. Nodes and edges will get broken, and you can score those things and see that go down and measure it. So the last section I'm going to talk about is how we can innovate with an attack graph. Everybody is looking for how you can use AI and generative AI and bring that to the world of InfoSec, and I'd say we're still at early days, and it's very promising. Because if there's one thing about modern AI that's true, is it really benefits from a great diet of data, and defenders have a ton of data. And so there are a bunch of generative AI applications to the attack graph domain. The first is, if you've ever played with a graph database and used languages like Cypher to write graph queries, it's a little different. It's not as easy and straightforward as writing something in SQL or Splunk or Cousteau, or if you know those languages. It's a little bit of syntax to wrap your brain around. And generative AI can help us just go write those queries for us. You type in plain English what you want, like who are the email administrators, how do I get to them, what could an attacker do from here, and those are the things that it can just translate that into a graph query. The second thing is, when these large language models are built, they're built on a snapshot of training data, like maybe the entire internet corpus that they trained. But they don't know about anything they weren't trained on. And so if you ask those models, like, what's the weather today? They'll say the weather as of a year ago when they were trained. The way that those large language models understand new context beyond what they were trained is with this technique called RAG, where when you type the question in the prompt, before it's submitted to the large language model, it will interpret the question and then go get more current data they think is related to your prompt or your query and put that hidden in the prompt that goes to the large language model. And so one of the things that you can use RAG for here is, if you're asking a question of an AI about, hey, this user is compromised, what is the blast radius from this? Behind the scenes, we can use RAG to query, do a bunch of pre-canned graph queries that involve that user account. What nodes and edges go from there? What permissions does this have? Do they have any super important permissions? And then provide that in the prompt to the AI. And then defenders can use this to predict where attackers might go next. The other strength I think that we'll see from AI is, today most of the world of detection engineering or alerts follows these steps. You gather evidence in the form of data. You get context associated with that alert. Maybe tell me more about the IP address involved, tell me more about the user account, are there any nearby alerts on the same account or same entities? And then some reasoning logic, some predicates need to be applied to go, is this a benign positive? Is this a true positive? What is actually going on here? To finally get a judgment. Well, that reasoning component that's here, if you look at GPT-4, the strength of the reasoning in GPT-4 was such that you look at the difference from GPT-3.5 to GPT-4. Like, it got college entrance exam level performance in the 90th and 99th percentile. That's how powerful the judgment, the reasoning ability was in the models. And one thing about these large language models is, you know, when GPT-4 came out, I don't know that many of us in defense had even heard of GPT-3 or that there was a GPT-2. And part of that's because the leap of power in these large language models was coming at such a fast rate. And the way that our CTO, Kevin Scott, puts it is, the power of these large language models is increasing at an exponential rate, but we only get to sample it like every 18 months because it takes months and months and months of compute to create these foundation models. And so if this is where the power of GPT-4 is and what it's doing, when GPT-5 comes out, think of the leap in reasoning ability that it will have. And so I think one thing we can bet on is the reasoning ability and the logic ability in generative AI is going to continue just to go by leaps and bounds. And what we can provide it to make it smart on the problems of defense is better structured data, more data, and all of the semantics that we know as defenders is present in the data. And so I think the combination of these things, an attack graph, how to query, model the entities in your network, the attack paths among them, combined with the kind of reasoning that's here in generative AI, I think we're going to see some really leaps and breakthroughs. So I hope you got a sense of what I was trying to bring the message here today, which I think there's a common language that exists between the world of attack and defense. I think the attack graph and this paradigm of a graph of graphs, that is going to be one that we can use to go work on together. And then it has objective ways in there to measure, build workloads around. We'll all be graph operators one day. The world of defense will be graph workloads, and AI will help us make it all better. So with that, thank you all for coming today. I look forward to talking to you throughout the rest of the conference. Thank you.